nth roots, radicals, and rational exponents. Our big thing today is looking to see how radicals, so like square root symbols, and exponents connect. You may have done a little bit of this in Algebra 1. I feel like maybe you did. Again, I never expect you guys to remember. So, definition up here. An nth root can be denoted by a radical symbol with an index of n. So, when we talk about an nth root, so square root, cube root, fourth root, whatever it could be, your index, so a little bit of vocabulary here, that little number indicating whatever kind of root, so where the n is called your index. Okay? And C, so your number under the radical sign is your radicand. So when I'm talking about a radical sign, that's your square root sign. It's just not always a square root sign. Could be a cube root sign, whatever the case is. So some important vocabulary there. The n is index. C is called the radicand. Okay, so looking, first of all, just being able to find all real nth roots. And we're going to talk about ways to do this, and we'll probably talk about ways to do this with the calculator and without. Actually, let me rephrase that. Without the calculator, but then we'll also possibly talk about some with the calculator. So, find the specified roots of each number. So in A, we're looking at all real cube roots of 125. Real just meaning we're not talking anything imaginary here. Okay? So thoughts on cube roots of 125? What's it mean if we're looking for a cube root? Yeah. What number times itself again is 125? And some guess and check will always work here too. Toph? 5. Because here's the deal, guys. What do you know? What's 5 to the third? Well, 5 times 5 is 25. Times another 5 is 125. So if 5 to the third is 125, what is the real cube root of 125? And that answer is 5. Okay? And I purposely on this section, I know we could use the cube root sign and say, what's the cube root of 125? But I'm purposely not doing that in this case. Okay? We just want all real roots. Okay, B. Real fourth roots of 16. So this time I'm looking for something that multiplies 4 times, right? Take a guess. Do some checking. Lucy, what'd you say? 2. Is that true, folks? 2 to the 4th is equal to 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. What if I say that's not the only answer?
Plus or minus.
Yeah. What about negative 2 raised to the 4th? What happens when you multiply a negative 4 times? It's a positive, yes? When you multiply a negative an even number of times, it's positive. So when we're asking for all of our real fourth roots here, what are we looking at? Plus or minus 2. Okay? So, does this mean I should have said plus or minus on part A?
No.
All right, okay, you've seen the difference here. If I would have said negative 5 to the third, a negative multiplied 3 times results in a negative. Okay, so remembering that fact that if you multiply a negative an odd number of times, it's going to stick a negative. If you multiply a negative an even number of times, it's going to become a positive. Okay, real fourth roots of 81. 3. Is that true? And if I don't have my calculator handy, here's what I'm going to do. I'm going to say 3 times 3 is 9. 3 times 3 is 9. And 9 times 9 is 81, just because my brain works a little bit better that way. Only answer? No? What else works? Yeah. Negative 3 to the fourth also works, doesn't it? So what are my real fourth roots here? Plus or minus 3. And again, notice all of these they're asking for all real roots. Okay? One last one. Real cube roots of 64. Four. 4 times 4 is 16. Times another 4 is 64. Only answer?
Yeah.
This time it is the only answer because we're back to an odd power, yes? So my only cube root is 4. Okay, so with this in mind, kind of got a little summary box here. I don't know if you guys read it before as we were going or not, but if it's an odd root, so in this example it'd just be the cube roots. Notice, in both of our cube root options, since those were odd roots, there was how many answers? There was 1 real root, and the sign is the same as the base, which I don't have a negative in here, but the difference would be, what if I had said real cube roots of negative 64? Well, real cube roots of negative 64 would have been negative 4, because 3 negatives would be a negative, okay? Even roots, so those are my fourth roots here. They would include square roots, okay? If there is a positive base, which is what both of these were, positive 16, positive 81, there were 2 real roots. That's your plus or minus. If there's a negative base, again, I didn't throw negatives in yet, but if there's a negative base, we can't take an even number and get a negative, can we? So negative base would have meant no real roots. Imaginary roots, yes, but no real roots. Okay? So notice I didn't use radical signs here. I was just asking for real, so you did have the possibility of a plus or a minus. Questions? Okay, let's look at the bottom part of this. A big part of what we're doing is looking at the connection between exponents and radicals. Okay, so interpreting fractional exponents. When we're talking about radicals, so square roots, cube roots, fourth roots, whatever, those can be related to exponents that are fractions. Okay, and so when you hear rational exponents, remember rational is anything that can be expressed as a fraction. We're talking fractional exponents. Okay, so connections. X to the 1 over n is equivalent to the nth root of x. So basically, when you look at the denominator of a fraction exponent, that's going to tell me what root we're doing. So if that said x to the 1/2, I'd be doing the square root of x. If it said x to the 1/3, I'd be doing the cube root of x. Okay, so that number in the denominator tells you what type of root you're looking for, what type of radical. Okay, now if you put something on top other than a 1, so this is x to the m over n. Notice that denominator of n is still the radical, so it still tells you what type of root, square root, cube root, fourth root. But that m is your power. So that numerator is your power on the x. It can either go on the x, or it can go outside the radical. Either or, order doesn't matter here as to whether you do the root then the power, or the power then the root. I usually look and see what's in my best interest, what makes the math easier. Okay? So, let's put these definitions into play here. Example A is asking us to explain what the fractional exponent means, and then evaluate. Evaluate meaning, what's it simplify to be? So, 16 to the 1/4 power. What's 16 to the 1/4 power going to mean?
16 to the 4th root.
Okay, so 16 to the 1/4 power is going to mean the 4th root of 16, right? So that is means 4th root. Put that 4 in the index position. Remember that vocabulary? The 4 is my index. It's my root. Okay, so that explains what it means. Evaluate. What is the 4th root of 16? 2? Is that one we already did? I forget.
I think so.
Yeah, we did. We did a fourth root of 16 up top. So 2 times 2 is 4, times 2 is 8, times 2 is 16. Now, I boxed that answer, but you know me well enough at that point. If I box the answer, what's that mean? That's my final answer, right? What did I not include? Plus or minus. Okay, so what you have to realize is when we talk about this with a radical sign, okay, or the exponent in this case, when we talk about that, we're just looking for the positive root. If they wanted the negative root, actually you couldn't have had a negative root in this case, but we only want the positive root. If they want us to say plus or minus, there would have been a plus or minus sign out in front of that 16. Okay, so up above, it was in words and asked for all real whatever roots. We want plus or minus. Anytime you're just being asked with an exponent, a radical, they only want the positive. If they want the minus, they'll ask for it. Okay? Okay, let's try B. 25 to the 1/2 power. What's 25 to the 1/2 power mean?
Second square root.
Okay. This is the second root of 25, which we don't usually say second root, do we? It's just the same as saying square root of 25. Doesn't matter which way you write that. It doesn't. You don't need to put the index of 2. Okay, if you don't have an index, we assume it's 2. Either way, what's this simplify to be? 5. Square root of 25 is 5. So this is our square root. Okay. Okay. What about 27 to the 2/3? Gonna mix it up? What's that mean to you? What do you think, Patrick?
Isn't it like the third square root of 27 squared? Something like that.
Okay. So the cube root of 27, and I'm not sure which way Patrick wanted me to write this. We could write it like this, the cube root of 27, and then squared, or you could write it as the cube root of 27 squared. Those are equivalent. You do them both in your calculator, they're going to come out the same. Now, here's my thing, and I know I'm more likely to go without a calculator than you guys are. That first one I can do without a calculator. My brain can do that pretty easily. The second one, I don't know about you guys, but I don't know 27 squared off the top of my head. But if I do 27 squared on my calculator and then the cube root, it's going to come up the same as, what's the cube root of 27? 3. And then what's 3 squared? 9. So my brain would do 3 squared and then get 9. Okay? That's what my brain would think. If you do 27 squared and then the cube root of that on your calculator, it works too. And here's what it comes down to ultimately. You guys are responsible for knowing how to do this, right? So you have to pick what makes better sense for you. You are going to have a calculator option on the test, okay? We'll talk later this chapter whether your calculator specifically is going to be allowed or if you're going to have to use one of mine. Some of your calculators do too much with square roots. So I will be banning some calculators for some of your calculators for this chapter. Just saying.
Do you have one like mine?
Huh?
Do you have one similar?
Well, you guys know what most of mine are. Those are definitely okay. The normal TIs are okay. Now, there's a couple in there that I have to pull out for this chapter.
Oh, graphic calculators?
No, you won't be using the graphing.
I can figure out how to do square root.
I don't know. Honestly, I'm not sure the graphing will do them, but those aren't really, those are more assigned to my pre-calc and calc kids. So. Okay, D. 32 to the 2/5. Have you started thinking ahead on it? What's this mean? 32 to the 2/5. Okay, so it's the fifth root of 32 squared, or what's the other way to think about this? The fifth root of 32 quantity squared. You don't have to think both ways. Most of the time, my brain is going to do the root first and then square it. I don't think we've talked about a fifth root of 32 today. It's an easy one if you figure it out. Fifth root of 32. You got to go small here. And that's what? Huh? You don't have that answer. You have the final answer, don't you?
No, I don't.
Okay. Fifth root of 32 is 2. And so then what am I doing? 2 to the second. 2 to the second is 4. Now, I don't know if I need to, but I'm going to real quick. Let me grab a calculator here. It's on the screen real quick. Okay, I just want to show you guys real quick that, for instance, on this one, I did the fifth root of 32. Do you guys know how to do a fifth root in your calculator? Yes, no? If not, you might want to make sure you know how. Usually, there is an x root. Okay, so on mine, I'm going to do the fifth, the x root. That's going to do the fifth root of 32, which is 2. And then I could do 2 to the second, which is 4. Now, my point of doing this is I could also have done 32 squared. 32 squared is 1024. Well, then if I do the fifth root of 1024, guess what? It's 4. So there's your proof. It works both ways. Okay, in case you hadn't quite figured that out. And if you're trying to figure out how to do certain things on your calculator, like cube root, fifth root, you're not sure how, please ask. All these calculators do it. We just have to know how. And whatever calculator you're going to end up using throughout this chapter, you're going to want to know how. Okay. Questions there? Okay, let's continue then. Evaluate each expression. Really kind of doing the same thing here. Just a little bit more with it. So A, 32 to the 3/5. What are you doing? What are we doing here?
I don't remember the wording. 32 and then 32 is cubed.
Yeah. The fifth root of 32 raised to the third power. Whether you put that third power is up to you. I'm going to tell you that this is how I'm usually going to think about it. Okay. What's the fifth root of 32? 2. What's 2 to the third? 8. Okay. B. What's changing?
Negative.
Negative exponent. 27 to the negative 2/3. So before we do anything, we've got to think about what that negative means to us. What does that negative mean to you? Has nothing to do with fraction exponents, just what a negative exponent always does. I don't remember. Let me ask this. If I say, okay, what's 2 to the negative second? There's your...
Oh, it's like 1.
Yeah. 2 to the negative second is 0.25, which is 1/4. I'm trying to get you guys to think backwards. It's 1/4, which is 1 over 2 squared, right? So what's a negative exponent do? It moves it to the denominator. So this problem, before I ever begin, becomes 1 over 27 to the positive 2/3. Anytime you see a negative exponent, step 1 is move that negative exponent to the positive. When you move it across the fraction bar, it makes it positive. Okay, that's a rule you guys already know. You just forgot. Okay, now can we do the math here? Should be able to. So now we're just thinking about this as 1 over. Okay, what's happening with the 27? It's the what root? It's the cube root of 27 raised to what power? The 2. So, what's the cube root of 27? Cube root of 27 is? We've done that one today, haven't we? Feel like it's somewhere on this paper. 3. And then we're going to do 1 over 3 squared. What's 3 squared? 9. So final answer? 1/9. Okay? Be able to follow these steps. Okay. One more. What changes up this time? We have a negative out front. Does that affect my exponent? No. A negative out front just means my final answer is going to be negative. Okay? Just worry about the 16 to the 3/4. So this is negative. How do we deal with 16 to the 3/4? It's the what? The 4th root of 16 to the 3rd. Maybe I should put that outside. Oh well. So, keep the negative out front. My answer is just going to be negative. What's the 4th root of 16? 2, right? 2 times 2 times 2 times 2. So, this is the negative of 2 raised to the 3rd. What's 2 to the 3rd? 8. So, negative 8. Okay, are you getting the hang of these exponents? Okay. Denominator is your index. It tells you what type of root you're taking. Numerator tells you what power you're raising the problem to. That's just the part you have to keep straight. And I'm hoping we've done enough of these now, you're getting that routine. Okay? Okay. When you're ready, flip to the back. And we're still looking at these radicals on the back. What we have to look at is what happens when you have variables under there. Okay? And the difference with variables is we don't know what type of number that variable is. Okay, that's the problem. We don't know, like on A, we don't know what M is. And M could be a positive, M could be a negative. And depending on the problem, that can make a difference. Okay, some problems it doesn't make a difference. Some problems it would make a difference because we can't always do certain roots of negatives. So, for definition, for any real numbers A, the nth root of A to the M is just going to equal regular A as long as we're talking an odd root. Okay, as long as we're talking an odd root, no issues. You just proceed with the problem as is. Because in an odd root, you can have positive or negative answers. It doesn't matter what that value is. The catch happens if it's an even root. Square roots, 4th roots, 6th roots, so on and so forth. When you do a square root, 4th root, 6th root in a radical situation, I can't have a negative answer. Okay? Because the radical only wants a real answer. It doesn't want imaginary answers. And so we have to use absolute value around variables if it's an even root, okay? So we'll talk about when to use absolute value, but you'll notice in the directions it says use absolute value symbols when needed, okay? Later on in this chapter, they'll just tell you to assume all variables are positive, and we don't have to worry about absolute value. But here in the beginning, they want us to think about this. So, simplify each expression, use the absolute value when needed, which will be on even roots. So, the fifth root of 32, m to the 15th. Thoughts here?
This was on free test and they got me.
Who was on pre-test? I gotcha. Okay. What if I break this up? Not saying you'd have to, but we're beginners. What if I break this up and say it's the fifth root of 32 times the fifth root of m to the 15th? Does that make it easier to see? And I'm not saying you have to break it up to get the right answer, but I'm just trying to break it into pieces for you. Okay, you can take radicals that are multiplied together and you can separate them. So that's an equivalent statement. Do you know the fifth root of 32? Is that doable? What's the fifth root of 32? I feel like we've already done this on the front page. 2? You'll get to know some of these, won't you? Fifth root of 32 is not 5. It is 2, like we just said. Now, the fifth root of m to the 15th. Can you rewrite that in a different form? We spent the entire front page going into radicals. I want to go out of a radical this time. So the fifth root of m to the 15th is going to be m to what power? M to the, you got a 50-50 shot here. 5 over 15 or 15 over 5?
15 over 5.
15 over 5, yes. Because this index is always your denominator, your power is your numerator. What do you guys know about 15 over 5? It's 3. So I have an answer of 2m to the third. Now, I'm going to backtrack for just a moment because it said use absolute value symbols when needed. Do I need to consider absolute value on this particular problem? This was an odd root. Can I do an odd root of a negative number? You can. Okay. I can do a cube root, a fifth root, because an odd number of negatives is still a negative. Okay, so that's possible. So because, and here's what I want you to check, because this is an odd root, I don't need to worry about absolute value. I'm good. We're done. This is 2m to the third. I'll show you the alternative here in a moment, of course, okay? But that's what I want your brain checking. When it says use absolute value as necessary, check what kind of root was it. This was an odd root, no absolute value necessary. Okay? Because I'm allowed to have a negative answer with an odd root. Okay. Let's try B. The fourth root of x to the 20th, y to the 8th. Does it help if I break it up at the beginning? Maybe it's going to be overkill, but you can think of this as the fourth root of x to the 20th times the fourth root of y to the 8th. How can we rewrite those? Okay. X to the 20 over 4, is that what I heard? Power over index times y to the 8 over 4. Yes? Okay. Now, clean up. These are going to clean up nicely usually today. What do you know about 20 divided by 4? X to the 5th. What about 8 divided by 4? Y to the 2nd. Okay. Now, I'm not going to box that yet. Okay, and I could have done this earlier, but I kind of waited. What kind of root is this? This is a 4th root, so this is an even root. Because it's an even root, we need to consider, I use the word consider, they may or may not stick, we need to consider absolute value around the problem. Because here's the deal. Because it's a 4th root, it has to be a positive answer. Okay? I can't do a 4th root of a negative number. That will give me an imaginary number, and I'm not looking for imaginary numbers. Okay? So, I need x to the 5th and y to the 2nd to both be positive. Okay? Tell me, depending on the value of x, is x to the 5th guaranteed to be positive right now? If we are trying to decide if we need to keep the absolute value. In other words, what happens if x is negative? What's a negative raised to a 5th power? A negative. So if x was negative, we have a problem here. So what we have to consider is that x to the 5th has to stay in absolute value. Okay? Because it's an odd exponent. And that could allow a negative to sneak in. Now, what about y to the 2nd? If y was negative, what would happen to y to the 2nd? It'd still be positive, wouldn't it? So y to the 2nd is okay. It does not need to stay in absolute value. So as a final answer, we're looking for the absolute value of x to the 5th times y to the 2nd. Now, I can shortcut this for you. If there's an even root, you consider absolute value. Where does absolute value have to stick if there was an even root? On the odd exponent. That's the shortcut. Okay, and that's going to work for you every time. Okay? We want to make sure this answer is positive. Y squared, I don't care what y is. It's going to be positive. X to the 5th, kind of depends. Questions I should answer on that? Okay, let's try another one then. Cube root of negative 8, a to the 3rd, b to the 9th. Can you think this through? I don't know if you still want it broken up, but I'm going to do it. Cube root of negative 8 times the cube root of a to the 3rd times the cube root of b to the 9th. Okay. What is the cube root of negative 8? Can we do the cube root of negative 8?
No.
Yeah. It's a negative. So if I do the cube root of negative 8, there's my proof. It's negative 2. Okay. What's the cube root of a to the 3rd rewritten as? You can't really get this one wrong. It's a to the what over what? 3 over 3. I'll clean that up in my next step. What about the cube root of b to the 9th? It's b to the what over what? 9 over 3, because that index, that root, is always your denominator. Okay. Clean up. Negative 2 is negative 2. A to the what? A to the 1st. Do I need to write 1? No. B to the 9 divided by 3 is 3. Okay. Before I box this, what do I need to consider? What type of root was this? It's odd. Is odd allowed a negative answer? Yeah, so do I need to consider absolute value?
No.
Nope, I'm done. No considering of absolute value because it was an odd root. I'm just writing that down, so I'm trying to get your brains in the habit of checking that. Okay, D. I've got to move quickly if we're going to finish this. Okay. Fourth root of 256, x to the 12th, y to the 24th. So I just rewrote this. Fourth root of 256 times the fourth root of x to the 12th times the fourth root of y to the 24th. Well, you can do some guess and check and figure out the fourth root of 256. Or you can use your calculator to figure out the fourth root of 256. What you got? 4. Okay? The fourth root of x to the 12th is x to the what over what? (12 over 4). The index is always the denominator. The fourth root of y to the 24th. Y to the 24th over 4, right? Okay. 4 is 4. X to the what? X to the 3rd and y to the 6th. And before I box it, what am I going to ask? Do I need to consider absolute value? Yes, that is an even. So I need to consider my answer has to represent a positive. Now, the question is, what needs to go in absolute value? What does not? What do you know about the number 4? It's already what? Positive. Do I need absolute value to make it positive? No. 4 is already positive. I don't need absolute value around a positive number to keep it positive. X to the 3rd. Could x to the 3rd be a negative if x was negative? It could. So what's that mean about x to the 3rd? It needs to go in absolute value. Could y to the 6th be a negative if y was negative? No. Anything raised to an even power is going to stay positive, so that one does not need absolute value. So x to the 3rd is the only thing that has to be an absolute value. Notice, does that go with the rule I said earlier? Basically, it's the odd exponents in even-rooted problems, right? That's what needs the absolute value. Now, I know you guys are looking at me and saying, no way, Mrs. Sargent. Yes way. This last section is easy. Hang with me. You kind of already know what to do. 2x to the 5th equals 64. How do I solve for x? Start with how do I get x by itself? I heard it. Divide by 2, yes? We divide by 2. I have x to the 5th equals 32. How do I get rid of a 5th power? Take the 5th root. How would you get rid of a 2nd power? You take the square root. How do we get rid of a 5th power? We take the 5th root. If you take the 5th root of the left, guess what? You take the 5th root of the right. The 5th root of x to the 5th is x. What's the 5th root of 32? 2. And because that was an odd root, we're done there. B. Divide by 5. I should have done C. Oh well. X to the 3rd equals, what's 320 divided by 5?
64.
Good. Okay. If it's x to the 3rd equals 64, how do I get rid of a 3rd power? You're going to take the cube root this time. Cube root of x to the 3rd is x. Cube root of 64 is 4. Okay, one last one. There's a catch on this one. If it's 2p to the 4th, how do we get p to the 4th by itself? Divided by 2. P to the 4th equals 81. Okay, Same old, same old. How do you get rid of a fourth power? We're going to take the fourth root. What's the fourth root of p to the fourth? P. What's the fourth root of 81?
3.
And
Negative.
plus or minus 3. Why did I throw in a plus or minus here? Okay, it's an even root. You guys have heard me say all along, when you take the square root in an equation setting, don't forget to throw on the plus or minus, right? I've been saying that all year long. Anytime you take any even root, throw on the plus or minus. An odd root, that does not apply. An even root, it does. Okay? I told you I could do it. You thought I was crazy, but I told you I could do it. Lesson 5.1 in Savas should be out there. Should be listed as due tomorrow. So make sure you take some time to get in there. I think it should go pretty quickly. Okay? If you have calculator questions about how to use your calculator something, please ask.